Yeah, now we will see the third example. So here, simplify the block diagram shown in figure and obtain the closed loop transfer function C of S divided by R of S. Verify the result by the signal flow graph method. This will be a typical university questions. Okay, so you should be very careful. You have to verify the result by the signal flow graph method. That is the way they are asking the question in the university examinations. Now, when you are observing the diagram, uh, what you can see there is um, yeah, here this uh, branching, feedback branching, it is, yeah, this will give some problems. So what you need to do, the previous problem what we did the same way, we have to move this branching point from here to here. When we are doing like that, what actually happening there? When we are moving like that, what exactly happening there? You can see that when you are moving like that, if now the signal is passing through G2 and we are taking the branch. When you are taking the branching before this and the branching signal, it doesn't have an effect, it doesn't have an opportunity to pass through the G2. So in order to compensate that, we should, when you are taking, if you are taking the branching before this, then G2 should be multiplied by H2. Okay, so when you are calculating the signal here, it is equal to G2 into H2. You forget about other all. When you are dealing, only you think that this much is there. Here the signal content is G2 into H2. Now if this branching if you are taking, so you have to, there is no G2 to multiply, so in order to compensate that, you have to multiply G2 into H2. So that is the important thing you should remember once. And when you are doing like that, you can see that now it is shifted here, so you are getting G2 will be multiplied by H2. Now this can be simplified easily. This 2 forward, you can add it, both are plus, so you can, this 2 you can add it, then that is multiplied by G3. So everything should this can be reduced into single block, 1 2 3. Yeah, now when you are doing like that, yeah, so you can see that G2 plus G4, G2 plus G4 into G3, so G3 into G2 plus G4, yeah, G2 plus G4 into G3. Now apart from that, now everything is reduced, but this is a node, means it is a summing point. After the summing point, the signal is, after the summing point there is a branch, you can see here. So in order to simplify this, what you need to this branching should be transferred to after the simplified block. Now when you are transferring, this is another when you are moving this branching point after the block, that means here you are getting H2 into G2. But if you are moving like this, whatever the signal is coming, whatever the signal here, that is multiplied by this much extra one multiplication happening. After that you are taking a branching. Then in order to compensate that multiplying effect, you have to divide it by whatever the terms here. So that is, you can see in the second diagram. Yeah, here. So we moved that deviating point here, that is moved to here, and you are dividing this term by this in order to compensate that. Apart from this all, now it is very easy. This is all are now in the normal format. Here you can use the general formula, this divided by 1 plus this into this, then it will be reduced. After that again this constitute once it is reduced, it will become a single block. Now that block and this again a feedback, normal feedback back, again you have to apply that the same formula. Then after reducing it, you can multiply by this. So it is now it is very easy to do the reductions. See, first reduction. So again after the reductions, you will get like this, like this and this multiplied, and you're getting the final answer, and like this, C by R. Now when you are converting that into signal flow graph, you can say that you will get like this. Okay, so as you are aware that there are one forward path, a second forward path, and how many loops? One is like this, second is like this, third is like this, fourth is like this, and fifth is like this. So there are two forward paths, and all the forward paths, you should see that this forward path is touching to all the loops. Am I right? This forward path is touching all the loops. So delta 1 is 1, and this forward path also touching all the loops. So delta 2 also 1. So now the forward path gain M1, you are getting this, M2 this, each loop values you can see here, the corresponding gain. Okay, and delta 1 and delta 2 are 1. Delta is equal to 1 minus, because there is no non-touching pairs, so only delta consisting of 1 minus loop gains, addition of loop gains only, that you have to calculate. So you are getting delta like this. Now as per the Mason's gain formula, M1 delta 1 plus M2 delta 3 divided by delta, that is equal to, you are getting a formula like this. So all of you now, immediately after the video, you take some time, you analyze the problem. You have to do by take your book, whatever I explained, keep it in your mind and do the problem by yourself, and while doing you will get an idea how to solve the problem. So don't become a lazy way, you should not approach this. Now we will do the next problem. Here obtain the transfer functional control system represented by the block diagram shown in figure 3.5 by the signal flow graph method. So here only signal flow graph method. The typical question I told that the previous case, that is a typical question. That means you are doing some block diagram reduction and verifying that by using the signal flow graph method. That is a typical question. Here you are giving some block diagram and you have converted it into signal flow graph directly, and then you have to solve the problem. So this is a problem. So here very important things you should understand here is the feedback. When it is coming here, it is diverting to two branches, and this is another feedback systems. And here you can see that it is another forward path. So when you are dealing with that, with this, you know that there are this is the corresponding graph here H2. So wherever one that should be very carefully you have to do it. Okay, so you should very carefully you have to do it. Now, yeah, concentrate here. You are, see here there is a branch. So till that branch you can see that here one R, then here that is x1, here is x1, and the gain is between this and this, you know that there is no block like this, so you're putting 1 here. Okay, after that this is the feedback path. Okay, this is the feedback path, and that is another node, that is node. You have to give the increment number to the suffix to the node. So this will become x6, this will x6. After that there is a gain 1 because there is no block here, so gain 1, and it is going to C. Now after this node, next node is x2. This is x1, this is x2. In between there is no block, so you are putting here it is 1 x2, and after that you are this is x3. In between the gain is g1. From x3 next is x4. This is this point x4, then this point is x5. From x5 till x6 again there is a gap, so here also you have to put the gain is 1 here, gain is 1, and from x5 back to x3, x5 back to x3, from x4 to again x3. In between, this also considered as a node, that is represented as x7 is coming, and from it will come to x7, x4 to x7, then x3. From x7 to here, all the multiplying gain factor is 1 1, you can see, and here it is -1 and here it is +1, and here it is G4. Now, when you're analyzing this circuit, how many forward paths? As you can see that there are two forward paths, and how many loops? As you can see that how many loops? This will be one loop, another is this loop. Loop means you have to start from a point, it should end that particular point only. So here we are starting and ending at that point. And when you are starting here, it will come here, and it will come like this. That means this third loop. And this is a path, forward path. It cannot be considered as a loop. So, there are three loops only. Then, if the forward path is touching all the loops, then the corresponding delta of that particular forward path is equal to 1. If it is not touching, then if it is not touching the loops, then that delta is equal to completely not touching the loops, then that delta of that particular forward path is equal to main delta of the circuit. So here, that is here all the forward. This forward path is not touching any of these loops. So M1, this forward path, it is having a gain and it is touching all the loops. So delta 1 is 1. M2, the gain is G4. Okay, M2, the gain is G4, and it is not touching any of the loop. So it is equal to delta 2 is equal to delta, main delta. Okay. So if it is not touching by 1, that means 1 minus that. Delta means if it is not touching by 2 loops, then 1 minus first loop plus second loop, like that. But here, as you can see that it is not at all touching any of the loops, so it is equal to delta only. So here you can see the loop and corresponding gain L1, L2, L3. Now delta can be calculated 1 minus L1 plus L2 plus L3. So when you are calculating it, you can see that you're getting like this. Now C by R is equal to M1 into delta 1 plus M2 into delta 2 divided by delta. M2 into delta 2 is same as delta, so you will get a M1 delta 1 by delta plus M2 delta by delta. Delta will cancel. So here you will get M1 delta 1 is 1 divided by delta plus M2. M2 delta by delta cancel, so you are getting G4. So this is your. Now, next problem, find the transfer function. Find the transfer functions. Find the transfer functions. Okay, find the transfer functions. So today you have to do second problem, third problem. Whatever the problem I'm explaining this, you study thoroughly this, because whatever we are learning, that you have to learn it properly. So that is my request. So here, find the transfer function Cs by R of S for the given system shown in figure. using the signal flow graph. Now here also you have to convert this into corresponding flow graph. So when you are converting it, yes, so very carefully, R with one, this is a node, this is another node, okay, and this is another node, here another node, here another node, here another node, then here another node. So after that one more node. So when you are doing like that, you can see that yes, the previous case it is very clearly here you have to see that the signal is coming back to here, and from here it is diverting to 2. That means the signal reaching here, it is passing through H3 and H4. When the signal is going in this here, that is passing through H3 only. So the corresponding signal flow graph, when you are converting it, it is easy, I feel. So it just looks like that. To see, you are having RS, X1, X2, X3, X4, X5, X6. After that, you can put this exists, then you can put 1, then you can put CS. That is better. One more node as a CS. Now you know that from there one is minus H2, another is another one line is coming, it is diverting to 2. First one is passing through H3 and it will go to X2, and from here again you know that it is yes, yeah, it will one is passing through H3, there is a junction, from that one is going to X2 and another line is going through H4, then it will reach XY. You see the diagram, see this line is coming H3 and it is going directly, but here there is any diversion that will pass through H4 to the just previous node. So that is why you can see here, yeah, from X6 backing, that is minus H3 and H4, another is H2, another is H3, and here one more H1. Now when you are analyzing this circuit, you can see that here there is only one forward path. There is no, see here all the arrows are towards back, so there is no other forward path, only one forward path. And how many loops? You can see that this will be the one, this will be the second, this will be the third, and this will be the fourth. 4 loops are there. And apart from that, you can see that there are these loops and these loops are non-touching, but this and this are touching, this and this are touching, and this and this are touching, this and this are touching, but this and this are non-touching. So that is the condition here. So there are forward path 1, the gain is G1, G2, G3. There are 4 loops, gain is written. Then the pair of 2 non-touching loops, you can see that there are 2 pairs, this and this. There are 2 pairs. Yeah. The pairs of non-touching loops. Okay. Then L12. You have to multiply the corresponding gain. So you're getting a big term. L12 non-touching pairs. That is used in that is used in your main delta. Delta 1 minus the loop gains, then plus the product of gains of non-touching pair loops, only one pair, so that is L12 that you will calculate it. Now you know that C by R is M1 into delta 1 by delta. Since there is only one forward path, so you are getting this M1 delta 1 by delta. So you are getting the answer like this. Substituting the answer. So I am stopping here.